Let's see how to design the air conditioning system of an architectural project with BIM Panasonic. To get started, we choose the interface language, create a new file, and save it to a path on our computer. To access the equipment library, users must be registered and logged into the BIM database. Depending on how the architectural project has been carried out, there are two possible scenarios: either that the architectural project is simply in CAD, or that it is modelled in BIM. For projects with CAD drawings, we uncheck the BIM project box. If, on the other hand, it has been carried out with a BIM modeler, we leave the BIM project box checked. If one of the site modelers is used, the BIM project will already be created on the platform, and the project would only need to be selected. When the modeler used is not from SIPE, we can create the project by clicking on Create New Project, and then upload the file with the building model in standard IFC format to the platform. Let's start with the simplest case, using CAD templates. This is the work area. We can activate the grid by clicking on this icon. Using the mouse wheel, we can zoom in and out. To move the view, we hold down the mouse wheel and drag the cursor. We can also orbit in 3D by pressing the Shift key and dragging. These features can also be accessed using buttons. Now, let's create a floor plan. After clicking on the option, we can find step-by-step instructions to follow on the left-hand side in the lower frame of the interface. We enter the reference, the elevation level, and the visible range via the distances to the top and to the bottom plane, and click on Accept. We click on the Go to the Work Plane icon to align the view with respect to the X and Y axes. We are also going to create another floor plan, 3 meters above the previous floor plan. We can see the result with the Show References icon. To design the air conditioning system for our project, the first thing we need is the building. Therefore, using the DXF DWG template option, we will import the CAD drawings with the architecture of the project. By holding down the Shift key, we select several templates at the same time. Once imported, we relate each floor plan template to its corresponding plan view. With the Zoom tool, we locate the floor plan within the template. Usually, we have to scale it. And for this, we use the Adjust the Scale of a Template tool. If we do not know the scale of the template, we can use Known Distance to adjust the scale of the template. For example, if a door measures 0.9 meters, we enter this distance and the scale is automatically adjusted in proportion to this dimension. Once we know the scale, 0.0012 in our example, it can be applied to the rest of the imported templates. If the building plan disappears when it is accepted, it can be located and centered by double-clicking with the mouse wheel on the work area. We start designing the system by selecting the cassette icon. In the pop-up window, all available models are listed in order from the lowest to the highest thermal capacity. If we want to place the cassette at a specific height above the floor, we select 2D mode and enter a displacement value. To carry out a design with cassettes or other VRF elements in line with each other, we hold the next cassette to be inserted over the one we have already entered for a second until a green cross is displayed, and we can move it over the reference line to the desired location. In the Object Snap configuration, it is very important to leave the Select Tracking Points Automatically option unchecked and the checkboxes in the Tracking section checked. Each time a VRF element is inserted, the program displays a controller indicating the reference point for rotating the element. In order to achieve 90-degree rotations, we hold down the Shift key. If we keep distance activated, when entering system components, we can enter the exact distance between them. We complete the system by inserting the remaining VRF components. When we have finished, we press the Escape key to finish entering VRF elements. Now we are going to draw the pipes. To do this, we work in 2D mode. The vertical sections required to reach the inlets are drawn automatically. To end a pipe section, right-click the mouse, as pressing the Escape key will cancel the entry of this section. We complete the system with the rest of the required pipes. Once finished, we click on the Save File icon. To check that the design is correct, in the Calculation group of the top toolbar, we click on Update Results. After this, error messages are automatically displayed on screen to guide us to the correct design. In the 3D view, we can see that the required vertical sections have been drawn automatically. We continue correcting and completing the system. The program will warn us if we make any mistakes when modifying and correcting the system. We will now place the outdoor unit on the roof. We start by assigning a corresponding template to the plan view of the roof. There are several ways to connect it to the interior system on the bottom floor. One of the simplest is to increase the visibility range of the plan view using the distance to the bottom plane option. Simply set it to 1 or 2 meters. We connect it to the intended pipe. To delete the pipe section that is disconnected from the system, we select it and press the Delete key. When updating the results, the error messages generated by the last modification are displayed. Once connected to the outdoor unit, we return to the range of the previous view to work more efficiently. VRF systems do not allow more than 3 pipes to be connected to a shunt, as noted in the error message. To correct this, we modify this route. When the system has been connected correctly, 2 lines are displayed when updating. In the 3D view of the system, we can see that the outdoor unit model is insufficient. With sizing, the program selects the indoor and outdoor unit models that meet the requirements of the system. In the example, even when selecting the largest model from the selected range, it is still insufficient. We therefore choose a range with higher capacity models. We update the results to check that the chosen model is sufficient. If not, we click on Sizing again so that the program chooses another model. Now it has selected Model 12, and all checks are shown in green. The indoor units have not changed when the thermal loads are set to 0. Using the Schema option, the program automatically generates the pipe diagram, which can be exported to DXF. It is also included in the report together with the results. We can change both the units of measurement and the number of decimals. The VRF list contains all the analyses, quantities, Y joints, pipe diameters, corrected capacities, schemas, and compliance with limitations. It can be exported to PDF. The program also generates drawings in CAD format. It also allows us to both print and save them on our computer.